Goedemiddag, dames en heren. Welcome to the seminar session. I would like to introduce Peter Manefeldt. He was a student of us. He completed his master's last year and he's working at the city of Cape Town, and he's going to talk on property evaluation and the tax implications of that. Thank you, Peter.
Hi everyone, most of you are familiar faces. I left you guys about a year and 2 weeks ago to go join the city, and it's nice to see everyone again. So initially, Prof. Ace asked me whether I want to come talk either about my master's research or about what I've encountered now in my working life, and I opted for the latter. I'd spent a bit too much time with my master's and didn't want to look at it much further. This started as a presentation specifically on how ratio studies are used to evaluate how well mass appraisal models perform. But at a certain stage, I found that it became too complicated without first introducing the process we use to actually perform the mass appraisals. Therefore, it's now turned into somewhat of a mass appraisal 101. Just introducing you to the data, some of the problems we face, how we tackle them, and then lastly ending off on the concept of the ratio studies and how we use that to determine whether our taxes are fair. So to start, we work for the city of Cape Town. It covers a very large area, starting there by Gordons Bay, where some of our colleagues stay, up until north of Manefeldt. Those of you that have been that have memories that go back a bit longer than mine might remember when it used to be 6 municipal districts before it was conglomerated under the Unicity. We have almost 5 million people staying in Cape Town, and they stay in almost 1.3 million formal dwellings. So each one of these dwellings must by law be appraised, get valuation, and that is what your property taxes are based off of. To give you an idea, about 15.3% of our funding comes from national government. So that is allocated from the money that you paid for SARS, to SARS, etc. And we have a projected budget of 75 billion rand. So that's a lot of money. We need to get that funding from somewhere. So a lot of the funding that we get come from the services we provide, mainly electricity generation and distribution, but also water and sanitation, solid waste removal, and other services that have surcharges and rates connected to them. We can't just come and charge you a tax because we feel like it. It needs to be grounded in something. The Constitution gives us the power to levy property rates, to fund municipal services. This is then empowered by the Municipal Property Rates Act that gives us the detail of what we are supposed to do and how we are supposed to do it. That must then be implemented at a local level by our rates bylaw, which I believe was passed in 2006. And then every year with the budget as one of the annexures that comes out, you have your rates policy. They're all the nitty and gritty. For us as a municipal district or metro, gets decided. So to give you an idea of the scope, we collect around 13.4 billion rands worth of taxes from our property rates. That makes up about 20% of the city's total budget. And the rates are 0.007159. That is your rate in the rand. That means for every rand value of your property, that is the number of cents that you pay in property taxes over a full year period. And then we have rebates for pensioners and indigents, social grants recipients, etc., so as not to overburden them. And we have a residential exclusion. So by national law, the first 15,000 Rand of your property is not taxed under property rates. The City of Cape Town gives an extra 435,000 Rand that is untaxed. So your annual rates that are payable will be whatever assessed value we ascribe to your property minus this residential exclusion times the rate in the Rand. Now, this residential exclusion does fall away if you have a property worth more than 7 million Rand at the moment. But this is the long and the short of it, where the taxes lie. Now, next question would be, where does this all go? Many of the services that you ascribe to government or local government are funded via your rates, your libraries, your public parks, your clinics, those types of services. And then we also contribute to the operations of the city as a whole by subsidizing our facilities management, our IT infrastructure, as well as funding some infrastructure investment and rates rebates. The largest proportion of your rates funding goes towards law enforcement. So that is your LEAP officers, your traffic police, as well as your fire stations and emergency services. Now, in order for us to levy these rates from you, we need to assign a value to your property. So this is where our team comes in. So once every 4 years, all properties within a municipal district must be priced at the price they would sell at an open market between a willing buyer and willing seller at a date of valuation. Our team, as the mass appraisal, is to take the sales from our current general valuation period, which is generally the last 3 years, and construct models to, in a systematic manner, appraise the properties. We are only responsible for the freehold residential modeling. We also do sectional titles if you think about retirement villages or apartment blocks, etc. But there we use slightly different, we apply slightly different techniques. So there are 3 approaches here. The first being your income approach, which is just a variant of your discounted cash flow. Those are mostly used for commercial properties. You take the best use of a property, and then you can calculate based off of the rental incomes from there what the value of the property should be. Then you also have cost approach, which is also mostly used for commercial, where you determine the land value of the property plus the building value. The building value here is then calculated by replacement cost. So both of these are used for commercial properties because you don't often have factories that sell. You don't have 15, 20 or 100 factories that sold in a certain area in Cape Town over the last 3 years that you can use to determine what a fair market value would be. But the golden standard is your sales comparison approach. Whether you are doing a single property valuation, which you might have had a property valuer do with one of your properties in the past, or whether you do it in a systematic manner like we do with mass appraisal. So here we have 3 inputs or 3 sets of inputs to our model, which is your land variables, your building variables, and other variables that come into play. So with your land variables, this takes into account anything that has to do with the placement or the land on which your property is based. So location is one of our most important drivers of value in the Cape Town market. And then we also look at what is the view from your property. We have a data collection manual that specifies exactly what our data collectors and valuers need to look for when describing which one of the 5 categories for your view you fall into. We also look at things like what is the environmental noise at your property, as well as the earth extent, your topology, the shape of your earth, etc. This is a non-exhaustive list. But this data comes to us from several different sources. So we have our data collection teams and our municipal valuers that actually go out, measure things. As Natalie said earlier, she had someone there at hers that was walking around with little measuring wheel, tuck, 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 saying you have this amount of paved area. But we get a cadastral file from the Surveyor General of South Africa that has every single urban mapped out on there. And we can then electronically go and calculate exactly what the area is that's covered, what is the perimeter, etc. We also have in the city 3D models of the topology, as well as wire cages based on LiDAR, so we can see what the height of your buildings and the different structures are, along with pictometry. So we have what are essentially spy planes that fly over the city as often as we can afford, but that needs to be budgeted in. And they come equipped with 4 directions of very highly detailed cameras that take pictures of all the buildings in Cape Town. So whenever we want to do a desktop inspection of a property, if I see an outlier, I think the property with these characteristics should not be valued at this price. Why did it sell that highly? I can go and pick a specific property. It gives me from the 4 wind directions a high quality image of the property, which I can also then use to calculate things like heights, volumes, extents, etc. And then for the location, we also have a dedicated GIS team. They are responsible for ensuring all our location data is properly tracked and maintained, and that it reflects correctly on our data management systems. That brings us to our building variables. So here we are mostly looking at extents. Over here, I just cropped out a section of a sketch of one of the houses, where based on your building plans, in-person inspections, as well as pictometry, we map out your building. Each area in your building is indicated on this, so we can distinguish between the different types of rooms and the different uses for areas in your property. And that is what we then use in our model. So heated extent is one of our most important variables, and that is essentially your enclosed areas that are not a covered stoop, for example, as well as the number of living rooms, number of bathrooms, bedrooms, number of stories, etc. Then we have, as also specified by that data collection manual I mentioned earlier, several variables, ordinal variables that describe your building. Describes the quality of the build initially, so that should not change over time, and then condition. As houses dilapidate, their value decrease. We want that to be reflected in the model. What security features are visible at the property, what building style your property belongs to, whether they are things like garages, etc., separate rooms or servants' quarters. Those all fall under your building value. Oftentimes we have attached areas, for instance, to the house, like attached garages, attached storerooms, etc. Oftentimes you don't want to distinguish between what the use is of the area, but simply that such an area exists. So we oftentimes agglomerate them into variables like total attached areas, or in the case where we are looking at the yard more broadly, total detached areas, etc. That is how they end up entering our model. And then lastly, other variables. These are your verandas, your pergolias, all those things, as well as your pools and some seldomly occurring variables like tennis courts and jacuzzis, etc. I mention these because they do throw a bit of a spanner in the works when we go about it, but that makes up our data that we use. So we also have other data that does not explicitly in our model. For instance, we need to keep track of the ownership data for everyone, every single property in the city, as well as transaction histories, etc. So we are a big department of 260 people about. So we have teams that are responsible for our corporate data team that's responsible for communicating with the deeds office to make sure that we're up to date on all the ownership information. We have teams that are constantly doing data collection. So I said we have 1.3 million properties that we are maintaining. So even if you work at a very fast clip with an army of people, you are bound to always be slightly behind the curve. So we try and keep that up to date as well as possible. And a large portion of our workforce goes towards that. But now that we know what goes into the model, we can look at what we are actually trying to model. We observe our sales, which is our market value plus some noise, right? Not necessarily additive noise here, but there's some noise that comes into our model. We are assuming with our sales price that there is a willing buyer, a willing seller. That is not always the case. Very often a property is sold, or portion of a property is sold because of a divorce that occurs, inheritance, a sale within a family, etc. If you let those sales slip into your model, it's over. You can start from scratch essentially. So we also have teams tracking down each of the sales, doing verification to see into which category it falls. We also need to assume that we are working in the same market. So if you open a textbook on mass appraisal, you will see that this is based off of supply and demand. Now you can imagine that in the city of Cape Town, the supply and demand curves look very different if you are in Khayelitsha versus if you are in Clifton. So we have to account for that. And then something else that slips in is if there is movable property included in the sale. I'm going to sell you my house, but you also get the bushwhacker that's in the garage as a little sweetener, so you'll come up to my asking price. This throws off our estimate of what the value of the property truly is. So we have to keep that in mind, but if we've kept that in mind, then we can try and find an assessed value, which is going to be our estimate of the market value, given our variables over there. The problem, or another small problem, is this little t over there at time, because we said that we need to value the properties as if they were all to sell on a given date. The date for this GV cycle is the 1st of July, 2025. So this needs to be accounted for. There is a very strong temporal dependency in the data. Here I just took the residential property price index for the freehold properties in the city of Cape Town from Stats SA, and I rebased it around our valuation date. So that is where you have your price index at 100, and there is about a 13% increase in prices over that period for this type of property in Cape Town. So this needs to be adjusted for. However, we can't just go and say, this is what Stats SA tells us. So we are going to adjust our sales accordingly. Sales from 3 years ago are going to get increased by 11%. And so we go forward because there is a large disparity in how the prices grow across our regions. And we'll get to how we adjust for that in a bit. But just to give you an idea, you might in one of the lower valued regions, say 1.2 million to 1.4 million rand house, you might have a growth rate of 4% in the prices over the last 3 years. Whereas if you go into the 5 to 7 million rand range, there you might have had a 25 to 30% increase in sales prices. We can talk about why that may have occurred afterwards, if we have a little bit of time. Then we also have some spatial dependence in our data, and it's quite stark in City of Cape Town. So we have to account for this somehow. And sometimes these jumps are very discrete. You can go from rather high valued houses to across the street, you have several price classes below that. So we do neighborhood delineation. So luckily we don't have to start from scratch every time. We have the spatial layers that we've constructed from the previous GVs. But essentially what we do is we find clusters of properties that have similar characteristics and that have similar market values that we measure both in the sales price over the last period as well as the assessed values in the previous GV. And then we can draw borders to agglomerate them. And prior to going to the city, I did most of my analysis in R. Now I've been forced to work in SPSS as well, but R is still my go-to for when doing spatial work. Terra map view packages are extremely useful. I suggest some of you check them out when you have a chance. But here on the right-hand side is just an example where we were doing a bit of QA to see where the changes were brought about in our neighborhood delineations, where there is a neighborhood here, Kalkfontein RDP, where we wanted the boundaries extended here at the bottom to include a new part of the neighborhood that had been constructed since the previous file was put up. So here we have input as a CAMA team, but this also falls on the valuers to advise and to also suggest new splits. Each valuer is responsible for a given region, and they are supposed to know their regions very well. So they keep track of any price changes or changes in the types of properties that may occur in a region and aid in this delineation. We have about 1,000 residential neighborhoods of these modeling neighborhoods that we've constructed, and additional 1,200 HOA neighborhoods, which is a description we use for neighborhoods that are very homogeneous, usually having being a gated community, so being gated off in some fashion. This is how we account for our location in our models. Now, this accounts implicitly for a lot of the different variables you might be interested in, such as what is the distance to the nearest hospital, schools in the region, etc. Those are all shared by the people that share a neighborhood. So we can account for all of that by including our neighborhoods as essentially dummy variables in our models at the end of the day. This also leads us to region definition. We mentioned that we need to make this assumption that we are working with sales from a given market. And usually your markets are geographically bound. So you would say this area we see as belonging to a given market. But in Cape Town, we do have a lot of, due to the history of Cape Town, we do have a lot of very stark contrasts that occur. So we agglomerate the neighborhoods into market regions based on price points. And that we usually do based on the median sale price or the median assessed values in the past. With that, we construct 16 market regions. So here we have on a log base 10 scale here on the y-axis, just the distribution of our the selling prices in our market regions. And to give you an idea of how this is distributed, the 25th percentile of the market has sales of about 900,000 Rand, 50th percentile 1.9 million, and 75 is around 3.3 million. Then we go all the way up to like 152 million Rand. Those would be your Nettleton Roads, your Cliftons, your Bishop's Courts. And you can see it looks like Cape Town has been hit with a hammer here in the middle. This is the region that is covered by Khayelitsha, Langa, the Cape Flats, etc., where we see lower house prices. The green here indicates nature reserves and such, where we do not have residential property. And you can see here, Atlantic Seaboard has extremely high property prices, as well as here nestled in the southern suburbs. And then we also have a pickup on Somerset West, Gordons Bay side. So you can see there are properties on either side of this mountain that, neighborhoods on either side of this mountain that fall into the same region. And so these are not geographically bound. But the argument would be that if you are looking to buy a house, so you are the part of the demand in a market, then you are set at your price point, what you can afford, and that is where you are going to shop around, regardless of where in the northern suburbs or in Somerset West it's going to be. So now we know where we're heading. Now we can get to the machine, or rather to the models that we employ. So everyone's craze is machine learning models. So there is interest in applying random forest, Bayesian additive regression trees, boosting, neural network. It's all models that we are investigating. We are an R&D team in times where we are not actively involved in general valuations or supplementary valuations. However, we need to adhere to international standards. And the international standards for mass appraisal is multiple regression analysis. That is changing with time as the explainability of machine learning models improves. And it is the research in our field specifically is exploring it. But for the time being, we use multiple regression analysis. So we can include the variables or transformations of the variables of everything we've discussed up to this point when we discussed our data in our model. However, our response over here can be quite heavy-tailed, as we often see with prices. So there is a transformation necessary. We then look at the Box-Cox transformation, which is the one parameter Box-Cox transformation, which is a power transform to find a transformation that would result in approximately normally distributed residuals for our regression model. So essentially, you perform the transformation by supplying a given lambda that goes into calibrating a model, and then the resulting residuals get tested. The go-to method for this would be there are some well-known transformations that are described by this. For instance, if you have your lambda equal to 0. It's a log transform. If it's equal to 1, you essentially leave the variable untransformed, and then everything in between can also occur. In SPSS, for instance, we run for the most common transformations. We then analyze the outputs, and we then see which of these most closely adhere, and that is then the model we motivate to use. There is also Wilks theorem available to do profile likelihood confidence intervals, which I've implemented in our R workflow, so that you can determine what the most appropriate transformation is. This can also be very sensitive to outliers. You can have 1 or 2 points that can point you into completely the wrong direction. So we've also started implementing leave one out procedures, seeing how the estimate and the profile likelihood is affected, to see which value should be excluded at this stage when determining your transform. Most of the models I've personally worked for have resulted in log transforms occurring. Then for our extents, yes.
Long time ago, statistical currently not varied. What does S mean in English?
Sorry, S here, I've tried to keep it constant throughout, is the sales price. So I should have been clearer on that. So yeah, we transform our sales price to get Y, which is transformed sale price that will go in as the response in our model. So this, we then also need to bring our extents in, and you often have some diminishing returns. You can't just keep on expanding a property or a house indefinitely and think you're going to have a linear scaling of the value. So these are transformed, often also through a log transform, but you can also use the Box-Tidwell approach to find the most appropriate transformation to apply. Then just briefly, our modeling workflow is largely informed by valuation theory. So for our model specification, what goes into our model? There we have theory that informs us which variables should inform value. For instance, we know that our urban extents and our heated area extents have a very big influence. We know that our location has a very big impact. So those will go in, and then the other variables we know are imported at that price point. For instance, if we go back here, we have environmental noise here. That has a negative impact on your property if you live in Gordons Bay and you are right on the sea road there and you hear cars coming past the whole time. That decreases the value of your property. However, if you are in a lower valued area and there's more noise around your property, it might mean that you are closer to transport, like the taxi ranks, closer to some of your business, some of your local businesses, etc. And there we tend to see a positive relationship between the environmental noise. Natalie, I can see you have a comment for afterwards on that. But the point I'm trying to make is the relationship between your variables and your price may change as you traverse your regions. So that is how our model specification occurs. For model calibration, ideally we would be able to put in everything that's in our model specification. We run some sort of regularization to come to our final model, because we all know that stepwise selection can have its issues. However, we need to ensure that certain variables have a certain sign, which we also know it does not make sense for your property to be valued lower because you have a swimming pool, for instance. So we are forced to semi-supervise it as it goes through to ensure that that we do not pick up on spurious relationships. For outlier removal, we use a sales to assessed ratio from the previous GV to exclude very stark outliers. So we do not expect, without significant changes happening to your property, that your value would increase 2.5-fold, or that the property in a region where you had property price growth would fall, say, below 70%. So there we exclude some of our values before the model calibration takes place. After that, we have one round of outlier removal based on Cook's D leverage, as well as your absolute standardized residuals. These should also then be followed up on to see whether they are actual outliers due to data issues, which very often occurs with our outliers, which we can then refer to our data collection teams to recollect so that they can come back into the model. And then we have time adjustments. So the time adjustments, how do we account for the change in prices over time? There are several ways in doing this. The first would be to simply see what was the average increase in prices in the region over the time. We escalate it by that value. Second one would be to fit some form of smoothing function. The low is, for instance, that was my first go-to when I faced this problem, and to adjust so that there is no trend remaining that can be picked up by the low is. However, there you can, for instance, work with the selling price per square meter as your variable. However, there you are only accounting for the heated area of the house, and you're not taking into account other explanations of other variables that can explain a decent portion of the selling price. So we include splines, linear splines in our model based off of a visual inspection of low-IS models that we perform beforehand to see where the trend seems to change. And if they make it into the final model, we then create time adjustment factors that can be used to adjust all our previous sales to bring them up to the data valuation. And then finally, any ordinal variables that we put in usually go into the initial model as dummy variables, then get linearized based off of the coefficients that went into the model to ensure, once again, that if the relationship is significant, that it holds the order, which it should. Then some places that we have bias creeping in. As much as we try to keep our data as up to date as possible, as with anything where you have measurement, there is error in your independent variables. So now X's here, and that errors in multiple linear regression or regression more broadly tends to bias your betas so that they are smaller in magnitude than they should be. This means if we look at the line we ideally want, the line usually comes out a little bit flatter. Now that can also be caused by omitted variables that might be of interest, but that have not been data collected or have not been data collected for your entire population yet, that are not coming in, as well as seldomly occurring variables. If you have a jacuzzi built in and you are one of 3 properties in your region that had a jacuzzi built in, your property might sell with that jacuzzi priced in, which is going to slightly inflate the selling price or the assessed value for all the properties in the region. And because that doesn't make it into a model, it's not applied. So then your property is also going to be slightly undervalued. So we account for that by subtracting the replacement cost of the seldomly occurring variable at the start of the analysis, and then after we have made all our predictions, adding it back for that property. And then, for instance, with our views, we can say you have a poor view, you have a fair view, average, above average, panoramic, excellent, for instance. If we do not have enough resolution in there, that means there's also some variance that remains unexplained, which also means that line of ours comes out flatter. So here we come to the ratio study. I'm going to speed up now. I see I've taken very long. So your ratio study tells you how well you have done with your mass appraisal model. So in mass appraisal, we don't look at any specific property to see how well did we perform on your property. It is how well we performed overall. So the first thing we look at is the appraisal level, which is to say the typical appraisal in your neighborhood or region. Is that in line with the sales price? So if we look here, our sales price and our assessed ratio, if we take our assessed over sales, we want that to come out to 1 for your typical. Then we also look at appraisal uniformity. There we have 2 kinds, horizontal uniformity and vertical. Horizontal uniformity and vertical uniformity. So if we want to measure whether you and your neighbors have been treated equally, so equally fairly, then we look at our horizontal equity. For vertical inequity, we look at whether a house that is in Rondebosch and a house that is in Clifton, for instance, which is much more expensive, whether we have been more favorable towards the owner of the expensive property or the owner of the cheaper property. How do we go about that? Well, we have our mean ratio, our median ratio, and our weighted mean ratio. We want all of them to be closest to 1. With your ratios, you can also have some outliers that skew your results. So we tend towards using the median ratio. Sorry. And we want this to be within 10% of your 100%, so your full appraisal level. But it must be within 5% of the jurisdictional median. So you can have something that falls within the allowable bounds of the level of appraisal, but for a specific neighborhood, it's further than 5% from your overall median for the entire market, which then means that you have treated that specific neighborhood unfairly and therefore should adjust there. So the level of appraisal simply tells us overall how fairly have we treated everyone. And we'll look at a couple of examples very quickly just now. Then for your uniformity, you have your coefficient of dispersion, which just looks at how much of a deviation there is of the ratios within an area. Then you also have your price-related differential, which has your average ratio over the sales weighted average ratio. And lastly, you have your price-related bias. So your COD can be used to determine whether you and your neighbor have been fairly treated or treated in the same manner. The PRB, the price-related bias, that tells you how much you are discriminating based on price. So the interpretation is here, your beta 1 will tell you as your market value, your estimated market value doubles, how much do we expect your ratio to change? By how many % do we expect your ratio to change? So if you, for instance, I don't think I need to explain that further. So a couple of examples would be if you had a mass appraisal model that is very naive, you just use a flat rate for your entire market. This would be your most regressive form of wealth tax when it comes to properties. Your level would be unknown because it would be wherever you set this. If you set this at your median property price, it would come in down here. You would overvalue the lower valued properties slightly, but you would severely undervalue your upper areas. And here the blue also indicates undervaluation. Then the second option would be to use tax bands. So this is what they have in the UK, where they say that your property is allocated to a certain tax band and everyone in that tax band will pay the same rate. That means that within each of your bands, you are going to have a overvaluation of the cheaper properties. So they will pay more rates than is fair, and undervaluation of the more expensive properties. So here you would see that your vertical inequity globally, so that price-related bias, would be very low. You don't show much bias, but in each of the markets, you have quite stark price-related bias there. Then you can also treat your entire market as a single market, right? Or treat all the properties as a single market. Here, for some of the reasons we mentioned earlier, with the biases that creep in, as well as the case that you now have changing relationships between your independent variables and your dependent variables as you move through the markets that cannot be accounted for by your model. You come out with a regression model that is still slightly too flat, or at least the assessed values that come out are slightly too flat, which means you tend to overvalue your lower valued properties and overvalued your higher valued properties. And this is a very big topic in the field, and is also what I've encountered most often with most models that you fit. So the other option is to, as we have done, split your market, as was done in the tax bands as well, and then fit your models, fit the model for each of the regions. Here you will still get models that are slightly regressive. And when I say this, I went and checked through all the previous audits and reviews. We tend not to have anything that is outside of the allowable ranges, but they all slightly lean towards regressive. But this means that while you might have slight regressivity, so slightly overvaluing the properties for your lower valued areas, overall you have a fair system, and locally it also performs quite well. Your level of assessment is close to, that should be a 1, is close to 1, so close to where we want it to be. And your horizontal equity, so within each one of these markets and each one of your neighborhoods, there's not too much variation between the ratios of neighbors. And then this is the last slide. This is used for audits and reviews. So we do our own ratio studies to see how well our models have performed. We also have outside entities that come in and audit us. They make use of valuation studies on the general valuation. The values we generate are not necessarily the values that end up on the roll. First needs to go through a series of checks by the valuers. Each property needs to be signed off. And if they deem that we have under or overvalued a property, there are processes with which they can override the valuations we've provided. Ratio study design looks much like any type of study design or experimental design we have seen in, or you might have seen in statistics. And we often, or an example of this is, we would like to stratify according to building styles. So we might have, with some of the new developments coming out of the requirement to have affordable housing in them, these may be properties that have a different building style. So now we stratify according to the building style, do our ratio analysis, and we may see that the level of assessment for these properties are much too high, which means we have significantly overvalued them because we have valued them with the rest of the properties in that development. If you have severe violations of your guidelines that are provided to you, then it may lead to reappraisal. So where the entire system needs to be restarted from scratch. And it also gives us some feedback. So it gives us feedback on how the market moves. So we can look at the assessed values we've supplied now that's going into effect on 1 January. And we can look going forward as new sales come in, how the assessed ratios change. We expect them to be very close to 1 across the board now. And as time increases, we expect these ratios to change. It can also give you an early indication of where we see neighborhoods in decline, where the prices are dropping, or neighborhoods that are gentrifying extremely quickly. We also run wagon wheels, is what we call them, which is essentially dry runs of the entire valuation process. And these can be used to determine how well our random forest that we are trying might be performing. Okay, that is it. I know I've basically covered the entire time allotted, but you guys are more than welcome to ask questions. Anyone that needs to leave can. Stefan.
I just want to make it so it's a single model for hectare.
No. So 16 models
Okay, yeah.
for the residential properties.
Each residential is a different one. Okay.
Yes. So the budget gets determined or the rate gets determined as part of the budget. So it essentially works that we do our initial valuations. Those values go to one of our neighboring teams that do the rates modeling, and they then know how large the tax base is. Then they need to make calculations on based on different scenarios with rates and different economic scenarios where people might not be able to pay, and our indigent line moves up. How much revenue the city is going to be able to generate. And then based off of those reports that get set up, they get sent up to the mayoral committee and to the city council, and they then make the decision which one of those scenarios are going to be followed. So it is, at the end of the day, not within our powers, it is a political decision that's made.
I'm at science, and I'm a reviewer for this for NITheCS currently. So I know nothing about property, right? I know nothing about property, but I was able to capture a significant amount of data from what you were saying.
Mm-hmm.
So my question is, I'll give you a very practical example. Look at KZN.
Yes.
Right? KZN with the mass appraisal, I'm sure they were up to standard with that, with all the processes that were there. But they couldn't predict that there will be a massive flood.
Yeah.
And they couldn't come into account, such as even the data that they're doing. They were not monitoring that there might be snow.
Hmm.
Do you get what I'm saying?
Yeah.
So my question is, if the property now it's at 100, I know this is terrible. Let's say it's 100 rand, right? If it's 100, and your stats say that this product is 100 rand. Now, when it's on 100, if all of these factors come into account, and you saw how terrible they were, and it was literally a masculine type of a thing, what happens to your model at that time?
So our model is now, we construct our model based on the last 3 years worth of data.
Yeah.
We make our predictions. Once it's been checked by the valuers and they've signed it, it's set in stone, right? So our model doesn't get changed again. However, there is, for instance, if you look into a mass appraisal handbook, there will be a chapter somewhere on earthquakes and natural disasters. So it is something that you take into account when you do that. If the property is significantly damaged, for instance, I don't know what our policy is, but I'm now just trying to think through the problem. if a property is damaged by a natural disaster, it could lead to revaluation, right? We have supplementary valuations, SVs as we call them, that happen a couple of times a year, that take the current state of your property and values it as that property would have sold at if you were to work back to the date of valuation. So come next year, February, the new rule has come into effect. Your property gets destroyed, gets put on the SV, it gets then gets lodged as a destroyed property and gets valued as that. And then it will most likely also come in under the residential exclusion line that we have set, which means that no property rates will be levied from that property.
So it's not like a stock thing, not like overnight, it's now at 50%.
But it could be a question of whether you need to account in your model for the risk of certain natural disasters occurring. But there would probably be an argument that the market is already pricing that in. And our by law, our task is to find a fair market value, not to assign the value we think would occur in certain circumstances, if that makes sense. Natalie, did you want to?
It's just like I would never go and buy formulated values. Like no way can help. But you know, if I got moved there, I'd have to.
Any other questions?
Yeah, I've got a question. So you stratify your data according to region, right? And then you apply a model per region that you have.
Yes.
So are these all your regions in this map mapped out?
Yeah. So the 16 colors here represent the 16 different regions, and that is the mapping out. So just by allocating to region, we can already capture a portion of the price information that's given by location. Just essentially the first adjustment that's done there that can be followed up by neighborhood adjustment. Yes.
Just to follow up on that, so the dark blue on top, are you putting that in the same region as the dark blue at the bottom?
Yes.
You do it by sales.
Yeah.
But how do you then, sorry, another follow up, how do you then cater for your geographic parameters that you have into the model?
So we don't explicitly input any geographic parameters other than the neighborhoods. We're going to be playing with a couple of different spatial models now going into our next period. But at the moment, this is what it is at. So the idea is that these fall into the same market by price point. So we handle them in the same manner, but because they also get accounted for as neighborhoods on their own, you can get the necessary adjustment in difference between Blue Downs and Atlantis, for instance. Yeah.
You need a special model for that. You just have a categorical variable says it's either there or in the south.
Yeah. So yeah, the problem we face more, it's not a massive problem, but it occurs here and there that you have very stark boundary effects where you have on a boundary you can have a significant change in valuation that's not necessarily quite as stark as the actual change in reality. So how you address that, if you address that, is I'll tell you next time. Yes.
So in an area, the actual sales have been really low.
Yes.
So like the last 3 years, interest rates have been high. Sales in general, I think, have been low. But I think within pockets, areas, you might find very few sales. So you know, what's to those areas? How do you assess the accuracy of the model?
I'm just going to repeat your model. My manager's online so that he can hear it. He'll love that you asked it. So the question was, if you had very few sales in an area, how do you assess that area? Yeah, so the way we do it is by doing neighborhood linking. So You often have it, especially with homeowners associations. I, for instance, know couple that were in the northern suburbs. They moved in there and the entire complex was filled within a couple of years. And essentially everyone in that complex stayed there until now they're all moving to retirement homes at 90 something. So for those areas, we can't, or we can make up sales, so to speak. So one option would be to get your valuers to go out, inspect use their expertise to then estimate this would be the sale price we allocate to each of these houses, essentially making pseudo sales and using those in our models. But the other method that we use is neighborhood linking. So we have a system of linking neighborhoods together based on price point and then characteristics such as the urban size, your heated area. So you have houses that are more or less the same, preferably very close, locations that are very close to each other. We also, to a certain extent, defer to our valuers over there to tell them, I don't have sales in this area, but it can't be treated as your typical house in the region. I need to link it to something. Which would be the most appropriate neighborhood to toss in this bag with?